Hello, my name is Mike, and welcome to my channel. These are the first 3 physics books I was ever given. These were given to me by a neighbor of mine who was a medical physicist, and he gave them to me as a going-away gift on my first year at college. And I'll be honest, they sat on my shelf for a really long time, and I did want to read them. I thought they were interesting. I did my freshman physics course, and I tried to follow along in these books. These are the Feynman Lectures on Physics by the legendary Richard Feynman, compiled by multiple professors at Caltech who created these really amazing volumes of information. This book right here covers most of all of freshman physics. Things like equations of motion, vectors in space, stuff that we talk about on this channel. And I'll be honest, at the time, despite seeming simple, this book was really hard for me. It felt dense in all the wrong spots. It felt wordy in all the wrong areas. I'll be honest, I struggled. I struggled really hard with understanding the content in this book. And I also struggled understanding all the content in the other books. Volume 2 covers a lot more of the modern physics topics. Things like electromagnetism, differential calculus of vector fields. That's like a vector calculus course. And then it gets into all sorts of electromagnetism in relativistic notation, tensors, all these really advanced topics in physics, and I was not ready for it. I thought I could just pick up the book and read it and, learn the math that I needed to along the way. And when I got into this stuff, I hit a wall. I couldn't get past some of these. So what I learned was, even though a book may be lauded and praised as some of the best texts on physics in existence, they can be tricky when you're not used to reading and studying physics. And sometimes what you need to do is take a step backwards to go forwards. So the next book that I bought was a book that I bought on my own, and it's this book, Physics by Cutnell and Johnson. This is a book that was used way back in one of my high school physics courses. And I remembered thinking, as much as I didn't like physics at the time, this was kind of a cool book. I mean, it was easy to read, it was fluid, I understood the material, and I saw it at a Goodwill for $4.99, so I thought, maybe I should take a look. I'll pick it up again. I'll see what the topics were in there. Because, when we do high school physics, I mean, it's high school, nobody really wants to be there, and for the most part, the courses were, kind of dry. And I picked this book up again, and when I had first read it, I immediately was like, oh, this is actually neat. I mean, you have your basic introductory physics stuff. You have things like kinematics in 2 dimensions and 1 dimension, which we are starting on in our Physics Foundations playlist. So if you do like that stuff, nudge, nudge, wink, wink, take a look. The description for the playlist will be linked below. But then we get into some of the more interesting stuff in physics, like the physics of energy, what energy is, electric forces and electric fields. That's one of my favorite topics in all of classical physics. Waves and sound, thermodynamics here, and we didn't cover too much of that in school, so this was all new concepts to me. And what made this book so cool is that at the back of the book, they gave you the opportunity to learn new stuff. They added some concepts in modern physics that were like distilled to the very basics of what they are. And so we have topics at the very far end of this book here, like ionizing radiation, nuclear energy, nuclear physics, special relativity, and I believe they very gently hint at some of the larger topics in quantum mechanics at the bottom here in particles and waves. So let me just go ahead and go real slow through these, and you can just take a look at the chapters here. We have the Intro to Math Concepts, Kinematics in 2 Dimension, both of which are we currently covering in our Foundations playlist, but then also all of these new ideas, building on things. This is a very common thing this book does, is it takes conceptual ideas like the forces and Newton's laws of motion, and it says, okay, now if I apply that to a situation where something's spinning, like a gyroscope or a pendulum, what happens? Do the Newton's laws still apply? Do things vary? Do they differ? And we have different, we call them the dynamics of uniform circular motion. It's a key stepping stone into understanding waves and wave mechanics, which is a key stepping stone in and of itself to build onto things like quantum mechanics. And so all this book will, if you read it like cover to cover, you would learn enough physics to be able to dive into higher level concepts. The only thing this book didn't do, which at the time I actually considered it a good thing, is it did not use calculus. There is very little to no calculus in this book. The closest you'll get is something like this, where they will tell you that velocity here is a delta a change in x divided by a change in time. And if you've ever taken a calculus course, a first course in calculus, you know that this is a very gentle way to push this idea of an infinitesimal or a derivative, and that's kind of what they imply, but they never go as far as to actually do it. See, they'll get really, really close, but they won't do the calculus in this book. So I recommend learning calculus while you can, because if you get into electric forces, and when I took my E&M class, about a year and a half after my first year of college, I remember going back to this book and I said, gee, it's amazing how much of the beauty of electricity and magnetism they left out in electric forces and fields. Make no mistake, it was a cool chapter, and we can go to that here, 512 it looks like. It was a cool chapter, and there's all these different kind of ideas that bubble up here about what charges are, and my favorite part are probably the vector fields of charged particles, the electric field lines. I think these are just gorgeous. And you can get the cool thing is you do enough math that you can start to feel the charges. We've practiced so many integration techniques on all the different charges and magnetic fields that it got to a point where you could picture the space being pushed around and the field being moved by these charged particles. And when I read chapter 18 in here, I didn't quite get that feeling just because it didn't have the level of calculus that was, it didn't have the rigor that a proper course did. But I think about that. That's almost a year and a half of college education that this book carried me through, where I was like, yep, this is great. I need this. And it served its purpose spectacularly. So you could pick up this book here, learn things like rotational kinematics, dynamics, which in and of itself is a fascinating subject, and then move into everything you need to know for specific engineering fields like fluids, temperature, and heat. All of these become really important if you go into engineering further, and learning them gives you a leg up, or if you just like kind of the funness of it, go to the nature of the atom, learn nuclear physics, understand this idea of like a probability wave inside the electron shells of an atom. It's beautiful stuff, and it's really cool to learn because this book will teach you the history about these things and the concepts, and then finally you'll get a couple like really easy softball equations to play with. There's tons of examples that are all written and worked through. You can see them right here. If we go to one of these example problems, here's what they do. They'll give you an example and they'll set it up. They'll say something like, this is acceleration and velocity with one-dimensional kinematics, which is the study of things that move. And what they say is they'll give you an example. They'll say, so suppose a plane in figure 2 right here, and they'll give you the nice drawings here. They'll say it starts from rest when time equals 0. It gives you an acceleration. Then it will tell you down here, once it sets up the problem, it gives you a full reasoning. It'll say, okay, so this is what's going on. These are the physical things that you, the physicist, should be paying attention to. And then it starts to give you a solution. So it basically allows you to get to that very crucial transition phase of taking all the reasoning and turning it into mathematical logic. And it'll walk you through all of that. It'll walk you through the algebra very slowly. It kind of holds your hand, because this is a book that's made to be understood by pretty much anyone from the high school level, like the upper high school level, sophomore, junior, senior year of high school, into college physics. And so if you take a college physics course, which is physics without calculus, a book like this would completely suit you for the entire year and a half or 2 years that you take the course, which is great. It's all in here. So I do recommend you take a look at this book, and you can see there's some conversion factors here, but I'm just going to leave you with a view of the table of contents here so you know what you're getting. I do recommend taking a look for these. If you go into a Barnes & Noble, you probably find one. Like I said, I got this at a Goodwill, and you might even find them at eBay or something too for a fairly cheap price. They're pretty popular books, and the hardcovers are definitely nice reference materials. So I wanted to make this video so you knew what this book was more about. If you do like it, do check out our Physics Foundations playlist, because I'm going through every single chapter of this book week by week, and we are doing lectures from the book, explaining the examples, doing the physics, and I'm kind of supplementing that with additional knowledge and trying to bring higher level physics into it to really show you the purpose of what we do in a book like this and why the math is important. So if that sounds interesting to you and you want to learn enough physics to pick up a bigger book like this, like the Feynman lectures on something, and go in and understand something like these quantum mechanics equations, start here. Follow me through with this Physics Foundations playlist, and you might learn something new. You might be able to build a lifelong love of physics. A book like this definitely had a large part in making me go from hating physics to being utterly obsessed with it, and it might just do the same for you. So thanks for watching, guys. Do like and subscribe, and I'll see you in the next one. Bye.